Hello dear friends, dear colleagues. I am pleased to welcome you to the first launch of the power plant, the autonomous closed-loop powder power plant. And let's go in order. Now I will tell you what it consists of and how it works in full, its cycle. So let's go, friends. We will repeat it with you. Surely you already know, well, many know that this is a screw compressor. It is responsible for air supply, meaning it compresses the air. And through this pipe we have a valve for the air. The compressor compresses the air and it goes into this kind of main filter. Here, please take a look at the main filter, and this is to do a rough air purification. Then the air goes into the dryer. Let's go. Take a look. From this side, here the air goes into the dryer. Here the air is being filtered. In this tank, and here in this tank, there is a special absorbent that collects all the excess moisture. After the air is prepared here, it is sent to the accumulator. Into our accumulator, into the receiver, as you can see right now. There is already prepared air there. 4 megapascals. You'll find out a bit later why we pump this air. And so, moving on, our air flows through this pipe into the feeder. The feeder, here is the starting powder. Come over here, friends, and I'll show you what this powder looks like. This is epoxy powder. It gets poured in here, into our starting feeder. And now, to show you, we poured in approximately about 4 kilograms or so. So, the air picks up right here. The powder is mixed and moves at a speed of right around 40 to 60 meters per second. It starts flowing through this pipe and enters our tribogenerator. The tribogenerator looks something like this. Naturally, here it is. Well, it's like an enlarged copy, right? Of course, we won't be showing it until that moment. We won't get a patent yet, but roughly speaking, friends, so you can see. And by the way, we showed this earlier. We also have a video on our channel where you can find and watch this tribogenerator. Air is supplied here, generation takes place, and these are just the extractors. Here, as you can see, we have 3 outputs from the extractor. This is a high voltage line. The air with the powder passes through the tribogenerator and flows through this pipe into our restorer. On the restorer, as you can see, there is a filter. This is a special filter so that the air is filtered just in case there's an accident or something goes wrong, right? So that the powder doesn't get into the air. This filter is necessary. And the station also releases clean air. So, its side effect, the byproduct, is clean, eco-friendly air. So friends, let's go over here. Let's get a little closer. Here we see 22 grounding circuits. This is exactly the restoration. And here we have the wires going. This is the grounding that I dug. Maybe we'll even include some footage showing how I did it. We also grounded this rack here so that, as you can clearly see, indeed precisely actually, to remove any excess charge and so on. We're heading to the most interesting part, which is fascinating, right here. In all of this, magnificence. This is of course a unique tribogenerator. But this transformer is no less unique. This is a transformer that works with direct current. This is a completely unique thing. No one has done anything like this yet. This is our individual development for which we will also receive patents already after we return from the Abidjan conference. So friends, here we see that high voltage wires come from the tribogenerator. In our transformer, here we connected from the transformer, made a special circuit breaker, so-called. Yes. Here we connected a tester that will show what the voltage is, and we've also prepared here. A T comes out from the transformer for us. Here we're going to try to light a bulb, try to turn on the angle grinder. Turn on the angle grinder and cut. Here is this sample. So let's try to cut it. So friends, I suggest we proceed as follows. Let's model a situation together. Just imagine that this power station is currently in a container. And we brought this container to a place where there is no external power source. External power source to start our compressor so that it begins to work. And the air went and the generation started. This is how we were with you earlier. We pumped it up to 4 megapascals. We have pumped it up specifically just for this modeling. In this particular situation, carefully. Here is the prepared air. We're now opening this valve. The air will flow and the generation will start. And while this air is passing through, there will be generation. And let's try with my colleague Sergei Vladimirovich to show you what indicators we are getting. Let's try to turn on the light bulb. Let's try to connect the angle grinder. Dear friends, I suggest we start our experiment. But before I open the air valve, let's do it. Let's make sure that the readings on the device are 0 volts on the device. And now, colleagues, look, I'm opening the valve here. And the generation will start. So the powder will be picked up by the air and our generator device will start. And Sergei Vladimirovich will tell me, let's just go again. Everything is absolutely perfectly fine. It's at 170 volts. Stable generation. Let's check and see exactly what we have right here, right now, currently. Don't come too close. So here we see the generation, we have it. The light bulb is working. The light bulb is glowing for us. It's a grinder, it's about 2 kilowatts. Yeah, damn it! We built up the voltage. About 200 volts. So, you see the generation. Now I'm completely closing the valve here, and right now the generation comes to a complete stop. There's no generation. We have no generation. Zero. The voltage is coming out. Here it is. And now let's see how much air we've used. Look, we had approximately 0.4 megapascals, and it dropped slightly to just under 2 megapascals. We didn't reach 0.2 megapascals. That is, we didn't spend that much, only a small amount of air and a small amount of steam. That is, as I said, we poured in 4.5 kilograms, and as we see, generation is happening steadily and well. Friends, this is our experimental setup, but it is still operational, as we've all just confirmed. We definitely need to refine it. This is not an industrial version. What does that mean? It means we can't hand it over for mass production just yet. We still need to work on it. We don't have an electricity distribution system in place yet. There are still some points that are missing. It's still too early to talk. First of all, this power plant is still operational. To generate approximately 16 kilovolts, but we still need 64 kilowatt of 128 and 512. We need to check how the power plants sum up. In general, there's still a lot of work to do. A lot, friends.